Now here we're going to do some practice with buffers. And so in our first question, we're looking at not necessarily a calculation, but we're just looking for the chemical equation for what happens when we add H plus to a buffer solution. So H plus is of course an acid. And so if we're adding an acid, then that acid is going to react with whichever species in the buffer solution is the base. So which of these species is the base? Well, it's going to be the one that has less protons. Here we have 2 protons, here we have 1 proton. So the HPO4 is our base. What's the charge on HPO4? Well, given that it's offset by 2 sodium ions, and as long as we recall that sodium has a +1 charge, this is -2, and so the product would be the conjugate acid of HPO4 2- or HPO4-. All right, question 2. We're trying to calculate the pH of a buffer system given some information. And this means we need the Henderson-Hasselbalch equation. pH is equal to pKa. pKa is given to us as 7.55 plus the log of the concentration of the base, that's 0.050 molar, over the concentration of the acid, 0.250 molar. Given that the base is at a much lower concentration than the acid, we should expect to get an answer here which has a pH that is lower than the pKa, and that is exactly what we get. All right, question 3 is a similar type of problem, but in question 3, we also have to calculate the concentrations. So we can do that for each of these. The concentration of acetic acid we take the amount we have, 25.03 grams, 1 mole over its molar mass. We can calculate its molar mass to be 60 grams. And we divide that by the volume of 1.3 liters. As a result, we find that the acid is 0.321 molar. We do the same thing with the base, 100.2 grams times 1 mole over 82 grams divided by the volume of 1.3 liters gives us 0.940 molar. From here, we just need to enter these values into our equation. So pH is equal to the pKa, which is given, 4.76, plus the log of the concentration of the base over the concentration of the acid. Here, the base is at higher concentration than the acid, and so the pH should be higher than the pKa. And that's exactly what we find. Finally, in question 4, we are looking for what ratio of the phosphates we would need in order to make a buffer with a specific pH. So the pH that we're looking for is 7.40. The pKa is 7.21. And that's plus the log of A minus over HA. So we can subtract 7.21 from both sides, and we get 0.19 is equal to the log of the base over the acid. Now notice here, I'm not looking for exact amounts for the acid and base, just a ratio. So how do we get rid of a log? Well, remember, this is, unless specified, log is always base 10. So we take this value, the base of the log, 10, raise it to this power, 0.19, and that is equal to whatever is inside the log. We can enter that into our calculator and we get a value of 1.55. So what this is saying is that in order to achieve the pH of 7.4, we need the base to be 1.55 times as concentrated as the acid. So for example, we could have 1.55 molar base and 1 molar for the acid.